Hello everyone, welcome to IGBits. We train, you learn. We shall continue our previous topic, statistics. Let's get started. I wish I would like to let you know that we have a YouTube channel, the channel name IGBits. Feel free to log into YouTube and then subscribe the channel. Your support is very important and essential for us to sustain the channel information, keep updated, and then your helping hand will support us to build the more knowledge and then sharing across, right, all the people who are like us to actually get the access and then learn the unseen topics. Okay, and feel free to share the channel to the your circle so that we can extend our helping hand to the rest of the world. Thank you all for keep staying with us and then keep help expanding our channel data to rest of the world. In last class we run through overview of the statistics, what are the topics that we are going to cover, but today we are mainly focusing on the measure of central tendency using mean, mode, median concepts. Okay, we extended look at like in a range and other topics, subtopics as well. What do you mean by measures of central tendencies for a given data? When you say data, what we are saying, data could be two ways, right? One is a raw data, other one is like a group data. So group data or ungrouped data, right? So in the last class what we studied is that we know the observations, because all you know the data that you are collecting as is, but that's what we can call the observations. You are collecting the data from the observations, right? So whatever the data that you're collecting, that is what you mean by the raw data too. So if you collecting data is like some sort of a series, the series would be something like that, let's say some numeric numbers like 5, 11, maybe 15, 19, 24, and 35, 49, 54, uh, and so on. Let's say 101, things like that. So if you data have something like this is called a raw data or ungrouped data, right? So you can actually try to extract the meaning if your data set is very small. In AIML, in artificial intelligence world or data science world, these data what we also called as a data sets. Okay, keep remember R series, data series. So now what we're saying is that if the data is too large, so if the data is too large, it's very difficult for us to extract the some meaningful information from it. And hence what we are saying is that data is going to be grouped together to derive some conclusions that drives next course of business actions. That is the reason why we were doing group data versus ungrouped data problem statements. Okay, summation of the problems. So now the question is, having said that we know the data and grouped data and ungrouped data, now let's talk about a bit of like a measure of central tendency means what. So measure of central tendency means central, you said like probably in middle there is a value, right? So it's a value that represents a total data in the sense like a total given data set, right? Given data sets, right? So we can also redefine its value. It is a value in a data around which, right, around which the values of other observations tend to concentrate. That is how you see. Let's say if I have a value, if I have a central value like this, if I tell the rest of the data is something, you know how this is concentrated around the central data is what I am trying to understand by using measure of central tendency. What are all the methods that are available for actually doing this? The techniques, methods, whatever it is, the commonly used MCT measure of central tendencies are arithmetic mean, median, and mode. Okay, so these measures give an idea about how the data is clustered or concentrated. Like if the sometimes like data may be very nearer to the mean, in and around of the mean. Sometimes some certain portion of the data may be extended towards the right or extended towards the left. What we can call it as a data skewing, left skewing, right skewing, and all. We will see in upcoming topics. Okay, are you clear? So measure of central tendency, mainly we were trying to use this one. Make a note of it. Arithmetic mean, mode, median can be applicable for both ungrouped data and then grouped data. First we will see from the ungrouped data, then move to the grouped data for problem solution. Arithmetic mean. So what is meant by arithmetic mean? So arithmetic means, so let's say we have observations, and then the all observations, what we can observations, we have a 2, 3, and 4. We have a three observations. These observations, uh, uh, you know, taking as an input to calculate your arithmetic mean. So what it says is coefficient obtained when sum of all observations. What is the sum of all? 2 plus 3 plus 4 is sum. Divided by number of observations, how many? 3. So what value you get it? 9, right? 9 by 3 equal to 3. So this 3 is AM, arithmetic mean. Right. So how do you define this one? Let's say you have observations like x1, x2, x3, xn, and then you sum them all divided by number of observations. Let's say n. Right. This is what is nothing but your arithmetic mean. Right. Arithmetic mean. You can rewrite like sigma x to the power of I 1 to n divided by n. This is what you can call it as a arithmetic mean. Clear? So let's find out a mean of first 5 natural numbers. What are our observations here when you say this? Observations would be first 5 natural numbers like 1, 2, 3, 4, and 5. So now how do you calculate AM? AM is like sum of observations. So 1 plus 2 plus 3 plus 4 plus 5. And then how many observations I have? I have only 5 observations. So but the total sum of these is like 1 plus 2, 3, 3 plus 3, 6, plus 4, 10, plus 5, 15. So 15 divided by 5. So how much you get it? 3. So arithmetic mean for the first, the 5 natural numbers is 3. Okay. Are you clear? So this is how I think we are going to calculate the arithmetic mean. Arithmetic mean for discrete series. What is mean by discrete series? I think we reviewed this topic as well, but we will recall one more time. Let's say we have observations x1, x2, x3, right, and so on, xn. And then each observation you maybe have like some frequency of occurrences. Let's say x1 observations you see as like a f1 times these observations appears in your series. Similarly for x2 the frequency observations are f2. For x3 the frequency of observations are f3. For xn the frequency of observations are fn. If you look at this way, then how do you calculate a mean for this for a given data, right? So how do you calculate? We have to observations and frequency product multiply them x1 f1 plus x2 f2 plus so on plus x2 xn fn divided by your number of observations. What are the number of observations in this case? All the occurrences. So f1 plus f2 plus fn, right? Frequency of our observations. This is what your total observations count gives rise to, sigma f. So I can say sigma x f, let's say I tends to 1 to n divided by sigma f I1 to n. Got it? So this is how we can calculate the mean for discrete series का arithmetic mean. You're clear? Good. Let's take one example. So I have an observations like 1, 2, 3 and 4, and then my frequencies are like 1, 2, 3 and 4. So look like this series is like this: 1, 1, maybe 1, 2, 2, 3, 3 and 4, 4, 4, 4. So if at all your series is like this, what you are saying is like, okay, my observations O and then my frequencies are what I'm counting. So I see like 1 is appears only one, 2 is appears twice, 3 appears thrice, and 4 appears 4 times. Now what we can do, how do you calculate mean for this one? The simple thing what you are saying like a sigma xf, right? So what is xf value here? If it is x, right? So what would be the my f? You can say 1 into 1, 1, 2 times 2, 4, 3 times 3, 9, 4 times 4, 16. Correct? So your mean would be sigma xf. How much? 1 plus 4 plus 9 plus 16 divided by sigma f means like this much, right? 1 plus 2 plus 1 plus 2 plus 3 plus 4. So if you see 1 plus 4, 5, 5 plus 9, 14, 14 plus 16, 30, 30. Divided by how much this one? 1 plus 2, 3, 3 plus 3, 6 plus 4, 10. So mean would be 3 for the given series. This is how. You can also calculate in general way too. 1 plus 2 plus 2 plus 3 plus 3 plus 3 plus 4 plus 4 plus 4 plus 4. Right? So, and then divided by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So if you look at this one, sigma f is 10, and then individual numbers also is like a 10. That's why either the n or sigma f both are same, right? So this would also gives like the same answer. Either you can calculate a normal, sum of observations by number of observations, or you can tabulate in a discrete series ka format, and then you should be able to get the same answer. These are the different ways to solve the problems. Are you clear? So sigma f is nothing but your n, number of observations. Okay. Let's solve this problem. So they have given xf values. When you look at this, I think that for sure this is a discrete series. Information is what is given, because you have observations and the frequency of observations are given. There is no class interval here. Okay. And the second thing, they were given as a mean, but they were asking, y value. Let me put a different color for my pen. This is what asked. So what we know for the mean, sigma fx by sigma f, isn't it? So sigma fx, you have to multiply this. 2 into 2 times 3, 6, 4 times 5, 20, and the 6 times 6, 36, and then 8y. This what your xf, and then you have to sum them, sigma f, isn't it? So 6 plus 20, 36 plus 8y. What about a sigma f? Sigma f means this one, 2 plus 4 plus 6. No, I'm sorry. So this one, right? 3, 5, 6. So 3 plus 5 plus 6 plus y. Okay. Now sum them. 6 plus 20, 26. 26 and 36. How much? 62. Isn't it? 62 plus 8y divided by 3 plus 5, 8. 8 plus 6, 8, 14. So 14 plus y. How much is given? Mean is already calculated. That is given 5.5. So you cross multiply both sides, then you will get. How do you calculate 5.5 multiplied by 14? How much you get this? 77 plus 5.5 into y divided by equal to 62 plus 8y. You can translate 5.5 to here, 6.2 this side. So 8y minus 5.5y equal to 77 minus 62, isn't it? So what is this value? 2.5 maybe, right? 2.5y equal how much this one? This is 5, this is 1. Agree? Okay, so then y equal to 15 divided by 2.5. How much? Any guess? This would be, you're right, this is 6. So y is a 6. This is how I think you can try to understand what is given versus like what is an ask. Accordingly, you can actually sum them to arrive the final answer. Okay, this good example. Important results of arithmetic mean. Let's recap whatever so far we discussed, right? When calculating the arithmetic mean, what we considered is like we consider all the observations. First thing, right? Value of mean depends upon all observations. Mean depends on all observations. That's the first thing. So what would be the second thing? Average of two numbers, let's say average of x1, x2. Average means like a mean. What you can say? X1 plus x2 by 2. So sum of observation divided by number of observations. That's what we calculated. So if you have a series like x1, x2, x3 till xn, and what you are saying like your mean would be sigma xi by number of observations n. Is it? For the discrete, for the discrete, what we studied? Can you recall for discrete what you studied? For discrete series, we were given like a x1, x2, x3, and xn. We were also given like a number of occurrences, f1, f2, and fn, so on. Fn. In this case, how do you calculate mean? Sigma xi fi divided by sigma f. This is how you calculate the discrete series come in. You're clear? Okay. What other things that we can think of? If at all you have a first n natural numbers, mean for first n natural numbers. There is a series shortcut value, right? N plus 1 by 2. This will give us direct answer. If you have a square, your 6 1. If you have a given square of n natural numbers, square of n natural numbers is given, then what would be the mean? A simple shortcut for the mean is n plus 1 multiplied by 2n plus 1 divided by 6. There is one more we have. So what is this one? Cubes of first n natural numbers. Cubes of first n natural numbers. In this case, how do you calculate mean? So the cubed formula n into n plus 1 whole square by 4. Okay, these are the few takeaways from arithmetic mean. I trust you are all clear. Good. Thanks for watching. Please like, share, subscribe, click on bell icon and leave the comments. Logically, we reached end of the session today. We shall continue remaining in tomorrow's class. Thank you all who are joined and participated actively in today's class. See you all tomorrow. Stay tuned to next session. Thank you. Have a good day. Bye bye.